Hey everyone, welcome to today's lesson. Today's lesson is going to be a continuation of what we did yesterday. In fact, I think it should actually be a little bit easier. Okay, so now let's just visually look at this graph right here. Okay, let's look at this graph. Now, I want you guys to ask yourself, as x approaches 4 from both sides, okay, in this particular graph, as x approaches 4 from the right side and from the left side, what does y approach? Well, the answer is pretty obvious. It's 0. Okay, so let me say that one more time. As x approaches 4 from the right side and left side, y approaches 0. Okay, so I can literally, what I can do is just, in this particular case, I can plug it in. Okay, I can plug in 4, all right, right here and right here. And 4 squared is 16 times 2, which is 32, minus 7 times 4 is 28, minus 4 gives you 0. Okay, so you can plug in 4 and you get 0, which matches here. Okay, now let's take a look right here. Okay, so all I'm trying to say is that you can, if if there is no graph, you can literally just plug it in to see what happens to what does y approach. Okay, in this case, y approaches 0. Okay, so you can plug in the 4. Okay, now let's look right here. Okay, let's look at this easy one here. Okay, now I'm looking at this guy right here, this green highlight. Okay, now let's say we're approaching it from the right hand side. We're approaching it from the left hand side. Okay, as x approaches 0 from the right hand side and 0 from the left hand side, what does y approach? Okay, you can see that it approaches -4. Okay, so again, if no graph was available, you can literally just plug in the 0 here. All right, and you would get 0 minus 0 minus 4, which equals to -4. So all I'm trying to say is that you can plug in these x coordinates of 0 and 4 and whatever else, okay, to find what y ultimately approaches. Okay? All right. Same goes here. This is I mean, I just put this example up here because it's supposed to be quote unquote hard. Okay? But you literally just plug in the 16 here and plug in the 16 there, and your numerator becomes 32 plus the 4, which is 36. Square root of 36 is 6. Okay. Log base 2 of 16, that's basically asking 2 to the power of what is 16? It's 4, and this becomes 1.5. Okay. And you can see in this particular example right over here, okay, as x approaches 16 from both sides, okay, as x approaches 16 from both sides, whoops, y approaches 1.5. Okay, and that's what I got right over here. All right. Now, so this example is basically the same thing. Okay, you need your unit circle here. Okay, so let's not confuse things. Okay, so basically you're just plugging in 0. Okay, you're substituting in 0 for these x's. Okay, this e to the power of 0, I'm going to write it over here. It's e to the power 0 minus tangent of 0 all over cosine squared of 0. This becomes 1. The e to the power 0 becomes 1. This tan of 0 is 0. Cosine of 0 is 1. And this basically becomes 1 over 1, which is 1. Let's see if it matches here exactly. Okay, so this one matches that one. Okay. And this B is like the example from the bottom on this previous page here. Okay, it's actually even easier. What you see here for B is actually easier than what we did already over here. Okay, last example. Okay, the second example. So in this case, okay, if we just jump to here, you're going to try to plug in 3 here, 3 here. Okay, but that doesn't work out, folks, because if you plug in 3 here, you do 3 minus 3, you're going to get 0 as your denominator, and as you know, that is going to be undefined. Okay, so what do we do in this case? Okay, what do we do in this case? Well, usually when there is a denominator, as an expression like here, x minus 3, x plus 3, 2x plus 3, you want to basically try to get rid of it. Okay, and the way you get rid of it, is, okay, let me just create a white space over here. Boom, boom. The way you get rid of it is by factoring. Okay, so you get x plus 3 on top, x minus 3, and you copy down that x minus 3 on the bottom, so the bottoms match, the top got factored, and look at what cancels. Okay, look at what cancels. The x minus 3's cancel, and you're left with just x plus 3. Whoops. Okay. And now you don't have to worry about a denominator because there is none, and you just plug in 3, okay, into x, and you get 6. Okay. All right. And graphically, okay, you're going to see that there's a hole here. Okay, there's a hole here. However, there is the graph just jumps to a dot right here. I think that's what is that, 3, 3, 2 or something like that? I don't know. Okay, yeah, 3, 2. This is 3, comma 2. Okay, but it doesn't matter because again, going by yesterday, this can be a hole. That's cool. From the left side, what is it approaching? Okay, as x approaches 3, okay, y approaches, I think that's 7. Okay, let me try to do some quick math over here. Oh, 6, sorry, yeah, 6. So as x, you can visually see, count it 1, 2, 3, 4, 5, 6. As x approaches 3 from the left side, y approaches 6, even though it's a hole. As x approaches 3 from the right side, y approaches 6, even though it's a hole. Okay, so that's why we got this 6. All right, so long story short, if you have a denominator that becomes 0 when you plug it in, try to do some factoring, okay, and then cancel. Sometimes there's one where you need to do factor by grouping today. Okay, maybe if I can find the slide, I'll put a review slide on how to do factor by grouping. But it's basically GCF for the first 2 terms, GCF for the second 2 terms, and just combine it from there. Okay. Okay, folks, that basically wraps up today's lesson. I want you to start off with a warm-up. That's from yesterday. Okay, it's yesterday stuff. Okay, that should be really fast. Okay, these here are pretty easy, especially 1 to 9. All you gotta do is just plug it in. Okay, just like we did in the first example today. Okay, here you also have to plug in. Here basically you also have to plug in. However, I think it's just a little bit more complex of a problem, but it's still definitely doable for you guys. These are going to be just like example 2 that we did. Okay, it's going to be very related to example 2, where you have to, if you plug it in the denominator, you're going to get a denominator of 0. So you need to find a workaround, which is to factor. Okay? All right. All right, folks. Well, that wraps up today's lesson. Thank you for listening. Hopefully it made sense.